Welcome back to our chemistry channel. Hope that you are doing well. In our previous class, I closed up with telling you about the characteristics of carbon. In today's class, we will be having a much clearer picture about this topic. Before we start today's lesson, let's start with a few funny jokes. Are you ready? Imagine a student is asking a teacher, Ma'am, will you punish me for something that I didn't do? What would be the teacher's reply? Obviously, no. And there the student exhibited his cleverness. He says, Ma'am, I didn't do my homework, ma'am. This is just a joke. Please don't try this in your real life. Okay, next joke. Do you want to become the father of physics? It's really simple. Just name your son physics. It's really funny, no? Here is another joke. The final one. School life of student. The most irritating moment is the morning alone. The most difficult task is finding socks. The most dreadful journey is the way to class. The most lovely time is meeting friends. The most favorite period is the lunch period. The most tragic moment is unexpected test in the first period. Most wonderful news is the teacher is absent. I know that all of you miss your school life a lot, but we can't go to school now. So let us pray that this crisis should come to an end. Then we can all meet. Enough of the fun time, guys. Let's go back to the lesson. Carbon and its covalent nature. As we have already seen, carbon cannot form C4 plus cation or C4 minus anion. So, how would it satisfy the octet rule? Can you tell the answer? But carbon has a solution for this. It overcomes this problem by sharing its electron. Yes, sharing is the solution. But it's not safe to share things now due to this problematic pandemic. So annoying. Okay, forget about sharing food. Let's talk about sharing electrons. For the 100th time, I'm telling you, carbon has 4 valence electrons. So it needs 4 more electrons. So let's see what carbon does. The method that carbon uses to overcome this problem is called covalent bonding. Remember the ionic bond which we learned about in our previous chapter. For remembering purposes, ionic bonds is for metals and covalent bonds is for non-metals. So let's see how these non-metals share the electrons. Let's take the simplest element, hydrogen, for example. You already know that the atomic number of hydrogen is 1. So it has only 1 electron in its valence shell. So it needs 1 more electron. You may tell me that it needs 7 more electrons. That's a no. Because helium and hydrogen are stable and are satisfied with 2 electrons, which is otherwise called duplet structure. Except helium and hydrogen, the remaining elements obey the octet rule. Come on, let's take 2 hydrogen atoms. In each atom, 1 electron is present, but neither of them are stable. Let's see how they share their electrons without fighting. Both of them share their electrons to form a covalent bond. It can be written in this way. In this, both the hydrogen atoms attain the duplet structure. Thus, both the atoms attain stability through covalent bond. In this case, hydrogen shares 1 pair of electrons. Therefore, a single bond is formed. Come on, let's see about the covalent bond in carbon. Similarly, carbon bonds with 4 other hydrogen atoms. Therefore, all the 4 hydrogen atoms attain duplet structure and the carbon atom attains octet structure by sharing electron with each other. Let's see the electron dot structure for this. The carbon's valency electron are denoted by X and the valency electrons of the 4 hydrogen atoms are denoted by a dot. So, the carbon atom forms 4 single bonds with 4 different hydrogen atoms. Therefore, forming compound called methane, which is used in our cooking gases. Come on, let's move on to the next topic, formation of double bond. Let's take oxygen. We know that its atomic number is 8, so the electronic configuration is 2,6. So, it needs 2 more electrons to attain the octet structure. While doing so, the another oxygen atom shares 2 pairs of electrons with it. Since 2 pairs of electrons are shared, double bond is formed. Finally, coming to formation of triple bond. Now, this time, nitrogen is the element of interest. Its atomic number is 7 and its electronic configuration is 2,5. Let's take 2 nitrogen atoms. Each nitrogen needs 3 electrons to satisfy the octet. So it shares 3 pairs of electrons. Therefore, both the nitrogen atoms have attained stable configuration. Since 3 pairs of electrons are shared, it is called triple bond. Hooray guys! We have finished learning about covalent bonding. Next, finally, allotropes of carbon. The element carbon occurs in different forms in nature with widely varying physical properties. As you already know, both diamond and graphite are formed by carbon atoms. The difference lies in the manner in which the carbon atoms are bonded to one another. In diamond, each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure. Whereas in graphite, each carbon atom is bonded to 3 other carbon atoms in the same plane, giving a hexagonal array. It looks cool, right? One of these bonds is a double bond and thus the valency of carbon is satisfied. Graphite structure is formed by the hexagonal arrays being placed in layers one above the other. These 2 different structures result in diamond and graphite having very different physical properties, even though their chemical properties are the same. Diamond is the hardest substance known, while graphite is smooth and slippery. Graphite is also a very good conductor of electricity, whereas other non-metals that you studied in the previous chapter. Diamonds can be synthesized by subjecting pure carbon to very high pressure and temperature. These synthetic diamonds are small but otherwise indistinguishable from natural diamonds. Fullerenes form another class of carbon allotropes. The first one to be identified was carbon-60, which is carbon atoms arranged in the shape of a football. Since this looked like the geodesic dome designed by the US architect Buckminster Fuller, the molecule was named fullerene. That's all for today guys. I hope you understood and enjoy the videos. We'll meet soon in the next video. Until then, bye from your Esther Miss. Bye.